Hello everyone. Today we will discuss about Hamming code error detection and correction methods. Before going to Hamming code, first we will see about the introduction of data communication. Data communication is the exchange of the data between two devices via some form of transmission medium. So the transmitted data can be corrupted during communication. How it is corrupting? Because of some external noise that will interfere our data communication, so the data that we are sending from sender to the destination will corrupt, or due to some other physical failures there is a chance for the corruption of transmitting data. So in such situation, input data that we are sending from the sender system cannot be the same as the output data reached at the destination system. This mismatch between the input data that we have sent from the sender and the output data that the receiver system received is known as error. So the mismatch is known as the error. Error can occur when the data is moved or stored from the sender to the receiver. So, the data errors may result in the loss of important or secure data. Most of the data transfer in digital system will be in the form of bit transfer. That means the data will be a sequence of bits. Bits means zeros or ones. So even a small bit of change can affect the performance of the entire systems. In a data sequence, if the bit 1 is changed to 0, or we can say that this bit 0 is changed to 1, it is called as bit error. So our data sequence or our data frame is a sequence of zeros and ones, or we can say that our data will be the collection of zeros and ones. So any one bit 1 or 0 will be changing their position, means that is known as error. So that is normally known as bit error. So we need an effective method to identify and detect the error in the sender side, and we need an effective method to correct the errors in the receiver side. So there is a method that is known as Hamming code. It is a set of error correction codes that can be used. So now we will discuss in detail what is Hamming code. Hamming code is a linear code that is useful for error detection up to 2 immediate bit errors, and also it is capable of detecting single bit errors. So what is single bit error and 2 bit error? So now I have a data 0110, that is 4 bit length. Now this data is sending from the sender machine to the receiver machine. So what is happening? In the single bit error, any one of the bit position, maybe in the first position or in the second position or any other position bit, is changing their state. Suppose the first bit position is changing their state. That means now the state of the first bit position is 0. So it will change their state, means it will convert or change it to 1. So the receiver side, they will receive 1110. This is known as single bit error. If it is immediate 2 bit errors, means any immediate 2 bit position is changing their bit state. That is known as 2 immediate bit errors. So here suppose the second position and the third position data is changing their bit state. So the receiver will get the output 0000. That is known as a single bit error and the multi-bit error. In Hamming code, the source encodes the message by adding redundant bits in the message. How the Hamming code is working? The Hamming code is used to detect the error in the sender side. So if we want to find out the errors, or if we want to detect the errors in the data frame, we can attach some redundant bits with our data. Suppose this is our data, we will attach some redundant bits, R bits with this data to detect or to ensure there is no data error happened. These redundant bits are mostly inserted and generated at certain positions in the message to accomplish error detection and correction process. Now we'll discuss what are the process or what are the steps for encoding a message using Hamming code. The process used by the sender to encode the message include the following three steps. First, we have to calculate the total number of redundant bits. Now, if we have 4-bit data, how many redundant bits we need to detect the errors or to ensure there is no error? If we have 7 bits data, 7 bits length data to be sent, then how many redundant bits are needed for the 7-bit data? If we are sending 11 bits data, how many bits we needed? How many R bits we needed to ensure that there is no error in the data or frame? So that is the first step, calculation of total numbers of redundant bits. Now next step is, or the second step is, checking the position of the redundant bits. Now suppose if we have 7 bits data, suppose if we need 4 redundant bits, where we will add these 4 redundant bits in our data frame. That is known as the second step, checking the position of the redundant bits. Last step is calculating the values of these redundant bits. Now suppose we have 4 redundant bits to attach with the 7-bit length data. What is the value of these 4 redundant bits? Now anyway, in that data transmission will occur by using